All right, welcome everyone. Today is Wednesday, the 3rd of December, 2025, and this is the Cluster API office hours. Cluster API is a subproject of Kubernetes SIGs, and as such, we follow their meeting guidelines, which can basically be summarized as please treat everyone as you would expect to be treated, or explicitly so, please be kind to each other. And if you have a question, please raise your hand and I will call on you. So at the beginning of our meetings, we like to take a little time to welcome new attendees and new community members. So if you are new to this community and would like to introduce yourself, please feel free to unmute and say hi to everybody.
Hi, my name is Natalie Fisher.
Hey, Natalie, welcome aboard.
Thanks.
Alrighty, I'm not seeing anyone else unmuting, so we will move on to the open proposal readouts. Let's see, do we have any open proposals that people would like to speak about currently? We got the independent worker topology versions and the external CA and cert sign. Do we have anyone who'd like to talk to either of those topics? Okay, not seeing any hands going up or people unmuting. So we will get into our discussion topics. Alrighty, so I like most of these topics are Fabrizio, so I don't know, Matt, do you want to talk about the 1.12 release or Fabrizio, do you want to talk about it?
I just put it on the agenda. I didn't really have anything to do with it. The release team handled
Okay.
everything.
Is there anyone here from the release team who would like to talk about the 1.12 RC1? Okay, well, everyone, please be aware that we've got release candidate 1 out for 1.12. And as it says here, it's useful for testing purposes only. So please take a look. Lots of changes, lots of highlights here. The release team is rolling on. It's one of the great parts about this project and this community is our release team is pretty amazing. So thank you for the hard work. And I would ask everybody who's interested in 1.12, please start taking a look at the RC1. And if you have any feedback, please leave it on the issue there. Okay, so if there's no questions about that, we will move on. Oh, Natalie, you don't have access to the doc. I think you need to join yeah, Joe's given the link there, but I think you need to join the mailing list or join the group, the Google group, in order to get access to the doc. All right, so without further progress, or without further delay, let's move on to Fabrizio. You've got the next release progress here, so please take it away.
Yep, talking about the release. So next week we will have GA. So this is the last week for providing feedback on 112. We already discussed that this is a release packet of new and great features. We already got a couple of valuable feedback, but we want more. We would like more feedback. So please test the RC1 candidate and let us know your feedback. Then a little bit of minutia. There are a couple of PR out for documenting these new features. It is a great way to learn about them, and also a review will be welcome. A review and feedback will be welcome on those PRs. And last is that we are still fighting a few flakes. Looks like the most annoying one were solved with RC1, but yeah, we're keeping an eye on it. So if someone is interested to this work as well, let us know.
Awesome. Does anybody have questions about the release progress or the status or anything Fabrizio just mentioned? Okay, I'm not seeing any hands going up or anything, so let's celebrate.
Okay, so we have two new reviewers, Andreas, which is now a reviewer from the machine pool part, and the PR merged today. And we also have Kartik that is doing great work on cluster API since some time, and now this volunteered to step up as a top-level reviewer. And I'm really happy about his showing up. So, if as usual, we give a couple of days of lazy consensus on those PR. But it will be great if you open the PR, give a thanks to those folks that are volunteering to step up for additional work in Class API.
Yeah, awesome to welcome some new reviewers on, and welcome aboard, Andreas and Kartik. I know you guys have been doing work around the community for a long time, but yeah, great to see you kind of codified in the owner's files, as it were. All right.
Okay, talking about good news and stuff to celebrate. This yesterday or the day before, we also merged the PR about the documentation for the infrastructure machine pool, and these are I'm really happy because this is the one of the first evidence that the new machine pool team is working well. And the contract is also very important because basically it defined the set of rules that all the provider has to implement. Let me say it formalized these rules, and this will make way simpler to keep going and merge more work for machine pools. So really happy to see this happening.
Yeah, that's awesome work. It's great to see that merge. Thanks to everybody there.
Yeah, Richard did most of the work, but the team. But you can see the team working behind the scene. So I'm really happy about this.
All right. Yeah. Does anybody have questions or comments about the machine pool contract documentation? Okay, not seeing any hands going up. Do you, Fabrizio, do you want to give us a demo today, or do you want to save it for next?
If that's okay, I think
Yeah.
that this time I'm ready.
Yeah, we're gonna have to go through we might have to go through the double handoff here. Christian, I'm gonna make you a co-host, and then can you make Fabrizio a co-host? Are you here, Christian? See if that works. Or if not, I'll just make you a host or something. I don't know. For some reason, like not all the names appear on my participants list. I don't know why this is.
Nope, looks like as co-host, I'm not able to provide host.
Let me upgrade you to host. Okay, now you're the host. So someone will have to make me host at the end.
Okay, so let's try to.
Fabrizio is now co-host, and I'm rotating back host to Valmico.
Nice. We've achieved the full Zoom handshake here. Thank you, Christian.
Okay, so before starting, yeah, maybe a note. This release is really packed by feature. Now I will try to demo two of them if we have time and you have patience to go through the demo, which are in place and chained upgrade. But I just want to mention that we also have taint propagation, or the first part of the proposal for taint propagation, which is super cool. We also have a big improvement in machine check that now supports defining rules for checking machine condition instead of in addition to checking node condition. And yeah, a couple of I'm probably I'm forgetting something else. So yeah, the release is really packed by great stuff, and it was super interesting to see many companies rallying on all those efforts, basically. Okay, so in place, what I have a cluster which has one control plane node, which is the first one of the first machine in the list, and 3 workers. Okay. Now, what I'm going to trigger is an in-place upgrade, and then I will guide you through what happens. And we already discussed it briefly the last meeting, but in place is accounted as an high availability. So basically, the upgrade will in place upgrade will happen progressively according to the mean unavailable and max surge rules that are defined in this cluster. So let's trigger the change. And yeah, second part is that we have a runtime extension behind the scene, and the test runtime extension is defined and implemented in a way that the failure domain change is performed in place, even if it is all fake, but in the provider that I'm using, but the principle is the correct one. So let's edit the cluster. Okay, so quick look at the cluster. I'm changing the machine deployment in place. The machine deployment is configured to have a max surge 0 and max unavailability 1. So it means that it can immediately start in place because it tolerates one machine unavailable. Okay. If it was the other way around, max surge 1 and max available 0, cluster PI first has to create a machine to give a room for an high availability, and then it will upgrade in place all the other one. Okay, so with this, I basically started, change, I apply. Let's get this started. So, and now I kindly ask you to look at the central frame of where I have the list of the machine, and I shift to a slightly different mode when basically I have a time machine, and I can guide you through the change in a sort of slow motion. Okay, so I go back. Okay, so here I'm just before the change happened. The in place, my change that was applied. So when my change is applied, as you can see, a couple of things happen and they are highlighted. So all the machine in the machine deployment are now detected as not up to date because they have to change the failure domain to reach the desired state. Okay. The second thing that happened is that one of the machine, the first one, immediately start updating in place. So as you can see, the phase is updating because it is updating in place. And also the machine is considered not available and not ready because in place means not available. So I move forward with the time machine. Okay, it takes some time. Let's move. Okay. Here we are where the in-place machine of the first machine, the in-place update of the first machine completes. As you see, it goes back to running. The machine up to date goes to true because now the failure domain has been changed, and the machine start becoming ready. Okay. In this cluster, I have a 10-second delay between ready and available. And what happened that after 10 seconds, finally the first machine become ready and available. So now I am back again to the desired number of available machine, and the cluster API start the second in place update of the second machine. So you can see second machine now, second machine of the machine deployment is updating again ready false, available false. So far, so good. I stop a second because I know it's sort of okay. I'm not seeing the chat. In case there are questions, maybe someone.
No one's raising their hand yet, Fabrizio.
Okay.
I do have a question though. At this point, the replicas on that machine deployment is 3, right?
Is
Like the
3.
replicas hasn't changed at all throughout this entire.
Yes.
Okay.
Because when you are changing in place, you are not creating and deleting. So the number of replicas just remain the same.
Cool. Thank you.
Okay. Keep going. Okay. Now the second machine in place update completed. Up to date goes to true. Ready goes to true. After some time, also available goes to true for the second machine. And finally, the in-place upgrade for the third one can start. And yeah. And after some time, also this one become up to date true and available true. So now we are back basically to the desired state. And that's, let me say, an example of a in-place upgrade workflow. Question?
So still no hands raised, but I have more questions. So
Yes, please go on.
How is the in-place update performed? Is the node rebooted or what? Like, how does it actually do the upgrade?
So the cluster API, from a cluster API point of view, we don't care. So basically, we are calling a runtime extension, and we keep asking this runtime extension. So we call at the beginning of the upgrade workflow, at the beginning to ask the runtime extension, hey, can you handle this type of change? Okay, and our test extension is capable to handle change of failure domain. And so he answered yes. Okay, and since this the answer tell us that there is a runtime extension that can cover all the changes, we start performing in place. Okay, if for instance we were changing failure domain and something else, and the runtime extension is not capable to cover all, we go to the regular path because it does not make sense to do an in-place update for few field and then do a rollout for the others. We go directly to the other. Okay, when the in-place update starts, basically Cluster API keep asking to the same runtime extension, hey, you have to update this machine, have you finished? And the runtime extension can answer, yes, no, I please ask me again in 15 seconds, or yes, I've finished. Okay, so in other words, the runtime extension is an extensibility point. The runtime extension can do SSH into the machine, can call an agent on a machine, run a daemon set. There are many strategies that you can use to do the in-place update. Cluster API it is all opaque. It just get the answer from the runtime extension. Does this make sense, Mike?
Yeah, it makes perfect sense. And so really like the implementation detail on the upgrade is left to the extension point. Like as long as it reports back to the core cluster API, whether it's ready or not ready or whatever, that's all that really matters.
And the reason, and just to give a little bit more context, is that the reason is that the complexity on the inside the machine is really high. I mean, consider an operative system, different ways, different booster providers, different, I don't know, hardening practice across company, etc., etc. So the idea is that we cannot, let me say, rule them all. We just give an extension point, and this is good enough for the first iteration.
Yeah, no, it makes total sense to me. I think that's like a really smart way to approach it because, like you said, there could be anything that needs to be done by a specific provider before it actually arrives. Lubomir has raised his hand, so please, Lubomir.
I missed the beginning of the demo. Is there some sort of indication on the machine deployment object that, like a condition that something is happening during the in-place update?
Yes. So uh, I'm thinking how to show. It's not easy to show, but basically in cluster API, since we want beta 2, we have a condition that from the machine bubble up to machine set, machine deployment, cluster. And so you will see if you are looking basically object up in the hierarchy, you will have a condition that shows you that something in progress. In this case, you will have a machine that is not ready, a signal the machine is not ready, and tells you it is not ready because it is updating in place, and you will have also a signal that a rollout is, if I remember well, that a rollout is in progress, because rollout changes, not rollout machines in terms of conditions.
I see, but this is reusing existing conditions. There's no like new condition for in-place update in progress or something like that.
There is a new updating condition at machine level
Mhm.
where we bubble up the full detail answer from the runtime extension that performed the grade. But basically what bubble up through the chain is the up-to-date condition. And the up-to-date condition will be false with a message, this machine is updating in place.
I
So
see.
yes, we are leveraging existing condition, but it seemed also it seems that it is a good way to do it, and also a key principle of this first iteration of the proposal was to not change the API. So we are sort of we are learning why we do, and we decided to avoid API changes as much as possible, so we can iterate faster and learn, and then eventually think to API changes in a more deliberate way.
Yeah, I think this is fine for the first iteration. I was wondering for follow-ups. There was recently a blog post by Google how they implemented rollbacks using the emulated versions. And I was wondering, is part of this in-place proposal or future iteration, there could be a mechanism to have rollbacks that might be relevant to edge cluster scenarios.
Yeah, this is an interesting question. So I read the Google blog post, and what they are doing is that when they, my understanding, I might be wrong, but what they are doing is that they upgrade the cluster, deploying a new API version, a new API server with emulating version set to the older version. So they only change the binary, and the downgrade is just replacing the binary with the old one. So my understanding is that they can downgrade only till before you enable new API version. So it is a slightly different upgrade workflow. But yeah, I don't know if we will ever get to downgrades. Currently, we are not discussing it. I'm keeping an eye on what they are doing with emulated version. My initial concern is that if we want to use the emulated version, your upgrade needs two upgrades. First go up, change the binary, but not the emulated version, and then change the emulated version. So it makes the upgrade progress a little bit more complex, which is something that I don't know if all the user wants.
Yeah, there has to be demand for that. Related to the topic of rollbacks, also, is there a way to cancel the in-place update? or no? Once
No.
it started, we are triggering the runtime station hooks, and at that point, the user should be recovering manually if there's some sort of a failure.
So I think the answer there are. So when you start upgrading a machine, in place upgrading a machine, this operation has either to fail or to succeed. So when working to a machine, this is a sort of unit of work. If it fails, remediation will kick you in. When you upgrade a machine deployment, of course, you start rolling out changes, but then you can roll back your machine deployment. So the desired state becomes the old desired state. And so what happens is that cluster API is like cluster API is going one direction, start changing machine, then you change the direction, cluster API adapt. So it stop changing the machine to go there and it start going toward the next, the other desired state. So yes, you user can, and it's also possible to pause or rollout, by the way, machine deployments. So you can change the desired state, you can scale up, scale down in the between of a rollout. You can roll back the desired state. Is possible also with in place.
Yeah, I think this is very valuable. And also going back briefly to the emulated version stuff, I never saw upstream tests for this, so that's a bit concerning. I don't know how they are testing it, so I think whatever, if Cappy decides to do anything about this, probably we should wait for upstream tests first. Yeah.
Yeah, I'm following. I have a tab open since weeks in my browser. Sooner or later, I will get there.
Thank you for the answers.
Thank you, Ruben, for the nice question. So, if you, Mike, if we still have time and if you want, I
Yeah.
can show
Yeah, you got 30
also.
minutes. So if you
Oh
want-
yeah,
yeah.
I can show also chained upgrade.
I do have one more question for you though about the input.
Yes.
So
In the
if
meantime, I'm creating the cluster
right.
for the other.
Yeah,
Okay.
yeah. In the in-place upgrades, we don't use multiple machine sets though, right? It's one machine set. It doesn't create like a new machine set where it does the upgrade from. Because I know like
Th-
in the I guess
that's a great question. So no, we create a new machine set. And the big difference and what we do for machine deployment is that when you do an in place, you basically move the machine from the old machine set to the other. So you change owner. Okay. And
right.
so that is necessary because what happens if in the middle of an in-place upgrade, then you do a change and you have to shift to a rollout. So at the end, machine deployment and machine set behaves like before. The only difference is that we have this move operation behind the scene. And this is also the biggest difference between in-place upgrade in machine deployment, that they have to handle the intermediate layer of machine set, and KCP, for instance. In KCP, in-place upgrade are simpler because you don't have to do the move operation.
Okay, and that makes sense. Like it's not what I would have expected, but now that you explain it, like it makes sense to me why it needs to be that way. So yeah, I appreciate that. That's cool. Yeah, thanks. All right, take it away on the next. Oh, I guess Joe's got a question.
Yeah, curious. So it moves on to the next one as soon as it's ready. And unfortunately, there's no way to plug into kubelet's ready status to have it do additional checks. Have you considered a way of adding, I don't know if you want to call it a hook or something, so that we could run canary tests on an upgrade and potentially roll it back if that canary is starting to fail?
No, I'm wondering if if exists something similar in regular deployments for pods.
Yeah, I don't think there is anything.
Yeah, and I give a little bit more context. So the implementation of machine deployment is, or let me say, started from the implementation of deployment in Kubernetes. So
Yeah,
we
that makes
share
sense.
most of the common design, and if it is, we don't have a similar construct. What is there are the same constructs that exist on deployment. So you can start and after some time pause. But I was also wondering. I don't think that it will be easy to put a hook in the between of an upgrade of a rollout, because the rollout decision is pretty complex.
Yeah.
And it has to consider, oh, no, it does not, it does consider, oh, that cluster is scaled up, scaled down, spec is changed, and viability. So it is sort of difficult to
Yeah, that's true.
yeah.
It is just a thought that occurred to me.
No, it is a good question. I don't think there is a simple answer. Christian?
I think an implementer of an in-place upgrade hook or of an in-place upgrade, I don't know how it's exactly called, could say, okay, if the first one fails and notice that in some way, and say, have maintain its own state for that and say, hey, okay, I'm deny further in-place upgrades for this cluster, for example, to get out of loop. But that's custom logic in that custom hook and not part of cluster API. Yeah, just one idea how something could be done, but yeah.
Yeah, this is an interesting idea. However, for machine set, the decision happen at machine set level. So when you have a machine deployment, basically there is only a call to the runtime extension that tells, can I move machine from this machine set to the other, no matter if you have 1 or 50. This is a sort of optimization, because the machine set idea is that all the machine in a machine set should be all equal. And so it doesn't make sense to keep asking the runtime extension, can you change the same from keep asking the same question. Yeah, it is an idea. I don't know. Yeah, we have to think a little bit if there is a way around to this problem. Okay, cool. Mike, is okay to move to the next demo?
Yeah, I think so. You got about 24 minutes, so take it away.
Okie dokie. So, change of context. We are talking about another feature that is called the chained and efficient upgrade. Simple explanation. So why chained and why efficient? Chained is that, so where we start. Today, when you do upgrade in Cluster API, you can go from one minor to the next one. This cluster that I created is 128, and you can go to 129. Then you have to wait. When the operation completes, you go to 130, and so on and so forth. Okay, so instead, with chained upgrade, you can edit the cluster and tell Cluster API, go up as many minors as you want. And what we will do now is that we are going from 128 from 132, which is go up by 4 release, and this allows me to show some detail about this feature. Okay, and this is chained. Basic REST API will perform for you a set of a sequence of upgrade, one after the other, a chain of upgrade. Okay, and why it is efficient? It is because Cluster API knows the version of all the workers in the system, and it will basically go through this sequence of version, skipping worker upgrade when possible. And so workers now are 29, basically workers are 28, they can remain 28 until the control plane is 3 version up. Okay, then also worker has to move to remain in the Kubernetes versions 2. Okay, so chained and efficient. Let's see a demo which is probably explain this better. So let's start the upgrade. Edit cluster base something, and I have to find version. Okay, so 132. Okay. Okay, I have, so the control plane is the one below, and it is starting upgrading, and as you can see, it's not going to 32 immediately. It's not a load. It goes up to 129. Okay, and I will and I also point out something in the down below. Down below, I'm showing the topology reconcile condition, which is the condition that gives most info about what the bigger detail about what is happening. So this condition is basically telling that the control plane is upgrading. 129 is already performed, but it's telling oh, it's upgraded to 130. And then it's also telling you the following steps. So in this condition, what you can see basically the upgrade plan for the control plane, but also for machine deployments. Okay. And as you can see, the upgrade for machine deployment is a subset of the upgrade for the control plane. They skip versions because it is possible. And so if we look back above, now the control plane is 130, workers are still at 28. Okay, and I block also down below. Control plane now started to 139, to go to 139, and what will happen is that as soon the control plane complete 139, control plane cannot continue to 132, otherwise the workers will go out of queue. So what will happen is that after upgrading to 129, the control plane stops and the workers start upgrading. They go from 28 to 31, so they jump basically. Okay, and yeah, if you follow below, basically below the condition are just telling for both control plane and workers what are the step what is the step performing, what is the step missing. So this, and yeah, if you follow this in slow motion, you have in more or less you'll get what I'm explaining. And so now the workers are almost completed the upgrade to 131. So we're just waiting for the second machine to become ready. Okay, now workers are 131, the control plane can restart his upgrade, his process. So control plane now is going to 132, which is the final step for the control plane. And as soon as control plane is finished, also workers will go up to 132 and we finish our chained and efficient upgrade. And yep, I think this is all. I don't know if you want that I go back into the upgrade in slow motion. But yeah, open to question also for this feature.
Yeah, amazing work. This is very cool, Fabrizio.
Yeah, maybe just an information that I forgot. So where the upgrade plan come from? So how Cluster API figure it out which step to perform? Okay, so the answer is that this is a feature for cluster that use cluster class. Okay, and if we look at this cluster, so this cluster is using a cluster class. Let me find it, which is called cluster class base. And if I look at the cluster class base, so this cluster class also has a list of Kubernetes version. Okay, so Cluster API basically figure it out which version we were. That was 128, the first one in the list. Okay, then Cluster API decide, it's not necessary that I go to the 128, 13, or 15. I don't care about this patch version. I just jump to 129, then to 129, 14, which is the latest patch version of the next minor, and so on. So basically, the upgrade plan was derived by Kubernetes version. And this is a way to define the upgrade plan. The other way is through a runtime extension. So you don't have to put Kubernetes version here. Cluster API call a runtime extension, and you answer basically the upgrade plan that I was showing. Okay.
Who's got questions? I guess I have a question. So I'm assuming that if you had a PDB or something that blocked upgrading on one of the nodes, that this would wait until the condition cleared before it would then do the upgrade.
Yes, exactly.
Okay,
So
cool.
and let me say, it is chained and efficient, but the building block, so the worker upgrade or control plane upgrade, are exactly the same as of today. So if you have a PDB blocks, if you your upgrade at the end it is a rollout. So if machine are not available, the upgrade blocks. So all the existing rules apply. It is just that the upgrade is performed one after the other, and workers are skipped when possible.
Yeah.
Just there is a lot of work behind this.
Yeah, absolutely. And like I'm glad that we found that bug in the autoscaler related to upgrading, because I'm glad we already turned off like downscaling. Because like what I'm thinking now is I would love to see the cluster autoscaler become more aware of the conditions that are being created by cluster API so that we could make better decisions on the cluster autoscaler about when to remove things and whatnot. But this is tremendous work. I think this is a really cool feature for Fabrizio. Thanks to you and everyone who's been working on it.
Yep, and as I said before, there was a buffer in place, and for chained, we had help from contributor for several companies. I'm super happy about this.
Yeah, that's really cool. Who else has questions? Anyone got questions for Fabrizio about this demo? Okay, I guess you answered everyone's questions with the demo, I guess. All right. Well, that was pretty much the end of our agenda. We don't have any provider updates or feature group updates. So if nobody has anything else, I guess we could take a few minutes of our day back. Anyone last minute ad hoc topics? Going once? Going twice? All right. Thanks to everybody for coming out today. Thank you, Fabrizio, for all the great demos and release work and everything. And yeah, see you all next time.
Thanks, everybody.
Thanks, bye.
See you. Thanks for hosting. Bye bye.